Determine whether the given function y equals sine x plus x squared is a solution to the given differential equation d squared y dx squared plus y equals x squared plus 2. Basically what this means is, can you use this formula here and make the equation to the right of it valid, or have the left-hand side and right-hand side equal the same value? So we can rewrite this differential equation as y double prime, same thing as d squared y dx squared, plus y, we keep that the same, equals x squared plus 2. So you can kind of see where this problem is leading you towards. All we have to do is take this formula here, take the derivative of it, where y prime equals d dx of sine x plus x squared, where the derivative of sine x with respect to x is simply cosine x, and derivative of x squared is 2x. Now to fully put this equation into that one, we have to take two derivatives, y double prime. So we also have y double prime based on y prime, which equals the derivative of cosine x with respect to x, which is negative sine x. Now plus 2. We're just dropping the variable and leaving the coefficient. So now we have all the tools to check to see if this is a good solution. Now let's plug in all of these variables. So y double prime, which we found to be negative sine x plus 2, plus y, the first equation, which is sine x plus x squared, equals x squared plus 2, just the normal right-hand side. And now all we have to do is simplify and see if this is valid. So, minus sine x plus sine x obviously cancels, which leaves us with 2 plus x squared equals x squared plus 2. Obviously, these are the same thing, and you can go one step further and just say, oh, 2 equals 2, which is obviously valid. Therefore, we can conclude confidently that y equals sine x plus x squared is a solution to this differential equation. And that's it. If you have any questions, please leave in the comment section below, and good luck.